चलो स्टार्ट कर लेते हैं कि atomic structure. ठीक है, what did we study? Okay, I told you that we studied how to represent an electron, right? I told you that the electron is not something, it's a negative charge that you find in a particular space. वो है क्या? You don't exactly know how it's behaving, how it's moving. ठीक है, so what you think of it as a negative charge that's occupying a specific region. And yesterday we talked about orbitals. I told you that there are regions around the nucleus where there's a very high probability of finding the electron, or where the negative charge is going to be located. Okay? And this region is not a rigid region. Okay? It's just a high probability area, that this is the space around in which the negative charge is going to be. So we did the s orbital. That meant that the negative charge would be located in a spherical region around the nucleus. Then you had a p orbital where the negative charge was located in two lobes around the nucleus. Then you had a d orbital. The d orbital had negative charge that was located in four lobes. This is a typical d orbital. And you had f orbitals as well, jahan pe the negative charge was, I mean, an f orbital has many shapes. Okay? We don't have to go into details about the f orbital, but this is one typical f orbital. ये सारा clear है? Last time वाला, is this clear?
Yeah.
Yes.
Now there's another thing, which is that the orbital can have orientations. Okay? Which means that, and I'll explain to you what an orientation is. So the s orbital has only one type. You can remember the s orbital. There's only one type of s orbital. Okay, just one type. Then you have a p orbital. Now, if you look at a p orbital, you would notice that it has direction. So the p orbital can have, I mean, what is a p orbital? That the negative charge is located on two sides of the nucleus. Okay, it's over here and it's over here. So the p orbital can have three different shapes. Okay, three different directions basically. So if I imagine this being the nucleus, right, and this is your x-axis, this over here is your y-axis, and then you have your z-axis. Okay, so that's your z-axis. Now imagine the nucleus being right in the center. Okay, so you've got the nucleus. Now the p orbital, what is a p orbital? So here's your nucleus in the middle. इसको मैं थोड़ा सा बड़ा कर लूं. So here's your nucleus in the center. Now the p orbital has direction, which means that the negative charge of the electron could be located on the x-axis. So that means this is the region in which there's a high probability of finding the electron, and this is the region where there's a high probability of finding the negative charge. Okay, so if an electron, so the negative charge of the electron could be located on the x-axis. Or what could happen is that the negative charge of what can happen is that the negative charge of the electron could be located on the y-axis. Let's call that the y-axis. Okay, so that's so the negative charge of the electron could be distributed on the y-axis. Or what could happen is that the negative charge of the electron could be on the z-axis. So let's call this axis the z-axis. So the negative charge of the electron could be distributed. Let's go a second. 1 second. So the negative charge of the same electron, not the same electron, it's a different electron. The electron could be occupying this z-axis as well. Okay, this one is a slightly, so it could be on the z-axis. So the idea is that this p orbital over here, the shape, okay, p orbital, remember, is a shape. It's a region around the nucleus. It could have three different directions. The electron could be either buzzing around on the x-axis, or it could be buzzing around on the y-axis, or it could be buzzing around on the z-axis. Okay, is that clear?
Yes.
Sir, z-axis being towards us, right?
In three-dimensional space. So basically the p, okay, it is towards you. So now the p orbital.
Yeah, okay.
Now the p orbital has three different types. There is a px orbital. I mean, the px orbital means that the orbital or the region around the nucleus that resides on the x-axis. Okay, that's a px orbital. Then you have a py orbital. And you can also have a pz orbital. So you can have three types of p orbitals. Now about the axis, you can remember this in the three-dimensional space. When I look at your room, kahin pe bhi na, no one, if you look around you, there's no axis labeled, right? If you look at your room, what is the x-axis? Which one is the y-axis? Which one is the z-axis? So remember this, these axes are arbitrary, which means that kisi ek ko bhi pakad kar, you can just call it the x-axis, right? But the only thing is that all three axes must be 90 degrees to each other. So whatever axis you choose, it doesn't really matter. I mean, what I can do is I can switch the axis. The labeling would switch. I can instead call this the x-axis, okay? And I can call this the y-axis. So the point is, the axes are arbitrary. Acha, to agar main wo karta hu, the labeling would also switch. Then I would have to call this one the py orbital, and this other one would be the green one will be your px orbital. Okay, the idea be clear hai ki x, y, z is arbitrary, right? I mean, in the real world there is no x, y, and z, right? वो आप खुद से assign करते हो, and you could assign it to any one axis. The only condition is that they should be 90 degrees to each other. That's it. तो जब आप atom को देखते हो, there's no labels given, because you just see this, right? So you just call this, let's call this the z-axis, let's call the red one the y-axis, let's call this one the x-axis. So you get your px, py, and pz. But once you use a reference point, then you have to follow that. कि अब हमेशा इसको x कहना पड़ेगा. Okay, once you select one as the x, you can't change that. Then until you solve the whole problem, that will remain the x-axis. Okay. Is this clear? This one?
Yes, sir.
So the same orbital over here, this p orbital, can have three different orientations. It could be a px, py, or pz. So three types. So there are three types of. So you got three types of p orbitals. Then d. For d, it's going to take a long time. Now the d is going to have orientation as well. So if you look at d, and remember for d, you don't have to draw it. A2 ke andar you'll have to draw it. Right now, I'm just giving you the idea. Okay, so there'll be no question about drawing the d. So d is in your course, but no one is going to ask you to draw it. So d orbitals. I'm just going to take a picture from the internet and I'll show you what the D looks like. Okay, कोई अच्छी picture. So remember, it's got 4 lobes, right? So probably just one second. अच्छा ये वो actually P का दिया हुआ है. If you can, ठीक है, that's your P orbitals. But coming back to the D. So I think you should be able to understand this. Well, it has all of them. So let's take that picture. I'm just going to post it here. So this one is coexisting crop. I can't. Just this part. So that's a D. Okay, now imagine this D in 3 dimensions. So even that D orbital, the four lobe thing, it will have orientations like the D could be lying completely flat. It could be in the XY plane, or it could be in the XZ plane. So it would be, I mean, the D orbital could be vertical, right? I mean, the nucleus is in the center, and the lobes could be uh, in the vertical. I mean, this plane, or it could be in the ZY plane, which is basically going to be this one. Okay. So the D has orientations as well. So the nucleus is right in the center, and the four lobes could be arranged in different ways. One of the d orbital has a different shape. TK, just ignore that. TK, don't go into that much detail, but one of the d orbitals actually has a different shape, but the other ones are just different orientations of the same thing. TK, declare that there are 5 different types of d orbitals. Is that clear?
Yes, sir.
And the same, TK, no one is going to ask you to draw this. TK, drawing is not important for this one.
So, sir, there are 5 types of d orbitals. So, must also have like, for example, dx orbital, d orbital, just
हाँ
like p orbitals.
हाँ उसकी भी naming इसी तरह है, but since it's I mean they're in different planes, I'm going to tell you their names are slightly different. This one is known as dx square minus y square. Okay, that's dx square minus y square. This one is known if the lobes are between the x and y axis, that is known as dxy. If the lobes are between the x and z axis, then that is known as dxz. If the lobes are between the z and y axis, then that is known as dyz. Okay, and this last d is on the z axis. It's called dz squared. ठीक है, तो इसकी भी naming उसी तरह but it's, I mean, you can't call it dx because it's not only on the x, it's also on the y. So even remembering these names is not important. ठीक है, d का बस knowledge होना चाहिए. Just the basic idea that there are 5 types of d orbitals, right? That's a typical d orbital, 4 lobes. The negative charge would be spread in 4 lobes, and there could be 5 different orientations for that around the nucleus. और फिर F की ना, F का तो कुछ भी नहीं पता करना. All you have to know about F is that there are 7 different types of, I mean, even the drawing is impossible for F. So there are 7 different, and most atoms don't have an F orbital. Okay, so you just have to remember that there are 7 different types of F orbitals. So starting with the first one, I'm just going to recap. Negative charge spread in a spherical region. There's only one type. I mean, even if you rotate it, it still looks the same thing. So there's no direction to a spherical region, right? But when it's a p orbital, the negative charge spread in 2 lobes around the nucleus, then there would be 3 different types of p orbitals. The negative charge could be on the y-axis, it could be on the z-axis, it could be on the x-axis. फिर इसका ये कि D, you can have 5 different orientations around the nucleus. ठीक है, so the negative charge could be distributed in 5 different ways. All of them would be called a d orbital with different names, right? dx square minus y, dxy, dxe, etc. और फिर F है. F का वैसे दिखा देता हूँ just for your general knowledge के F orbitals, right? So the F orbitals are these. बल्कि ये अच्छा ठीक है, that's how the negative charge would be spread around if it's in the F orbital. Okay, this is the one that I drew with 8 lobes, right? So the negative charge, if and very rarely an electron will be in the F orbital. Okay, so the negative charge would be spread in any one of the ways shown over here. Okay, तो बस F का थोड़ा सा idea रख लो. So is this part clear that orbitals will have different orientations? Is that clear?
Yes, sir.
Yes, sir.
And remember, for your case, you'll be specifically asked to draw this, which is the easy ones. You'll be asked to draw the S orbital. You'll be asked to draw, maybe they'll ask you to draw, they'll give you the axis. They'll just ask you to draw PY. So you just draw PY. It might ask you to draw PX, draw PX, that's it. D key drawing, that's not important now. A2 can you'll be asked to draw that. I said, moving on. So we've got these orbitals, right? Now there's a thing called subshells. Okay, so there's a thing called subshells. Now remember this thing. Okay, the electrons are always in orbitals. Okay, so we always talk about orbitals. What a subshell is basically a group of orbitals. What you do is a subshell is basically okay, this one, this blue one, this one over here, the one that I'm showing you, that's your PZ orbital. This is your PY orbital. This is your PX orbital. Now, if I group all of them together, right? इनको इकट्ठा करके ना, I think of this whole thing. ठीक है, I mean, if I pick this up, this whole thing, right? If I just take this whole thing, right, then that entire thing is called a P subshell. So what is a P subshell, or what is a subshell? It's basically a group of orbitals that you group them together, but a group of same type of orbitals. कि इन सारों को मैं group करूँ ना, that's called a P subshell. Clear? If I group all of these orbitals together, that's called a D subshell. Is that clear? Okay, what a subshell is?
Yes.
So usually when we talk about electronic configurations, we usually talk about subshells. So I'm just going to refer or talk about subshells at the moment. Subshell is, so what's a subshell? So a subshell is, one second. So a subshell is a group of degenerate orbitals. And degenerate basically means same type. I mean, it's a word that's used to describe same type of orbitals. Okay, so for example, PX, PY, PZ are actually the same type of orbitals. The direction is different, but they're kind of the same. Is that clear?
Yes, sir.
So starting with the first one, I'm going to list this down. Starting with the first one, S subshell. So remember, the S orbital has no types. There's only one type of S orbital. Okay? So starting with the first one, the S subshell. So it only has an S orbital, that's it. So then you have P subshell. So P subshell will have 3 P orbitals. Okay, so whenever you hear the term P subshell, that means you're talking about PX, PY, and PZ together, not of them individually. So then you have D subshell. So when you talk about a D subshell, you're talking about all the 5 d orbitals together. So it's dxy, dxz, dyz, and you have dx square minus y square, and it is dz square. The one, the rear one, that's the F subshell. And the F subshell will have 7 different F orbitals. So these things are your subshells. And so coming back to so coming back to orbitals. One thing that we did not discuss is how many electrons can an orbital accommodate? Like if there's a spherical orbital, right? How many electrons can actually fit into it? If there's a p orbital, how many electrons how much negative charge can it accommodate? If there's a d orbital, how much negative charge could be distributed in one orbital, right? So the answer to that is that a typical orbital, any one of these orbitals, can have a maximum of 2 electrons. So if there's a spherical region around the nucleus, the maximum number of electrons that could be buzzing around in this area, the negative charge of 2 electrons can be accommodated in this specific space. ठीक है? Clear है?
जी सर.
तो यहाँ पे मैं ऐड कर देता हूँ कि each orbital has a maximum room for 2 electrons. So let's so maximum 2 electrons. You can't have more than that. I mean, that's a fixed. I mean, you can't have more than 2 electrons in this region. Similarly, you can't have, if the negative charge is spread in the p orbital, this entire p orbital can accommodate the maximum charge of 2 electrons. That's about it. Not more than 2. That's a fixed number. Okay. So if you go back to subshells, so the first subshell, the first one, it can have a maximum of 2 electrons. How much do you think can the p subshell accommodate? Like I'm talking about the subshell, entire subshell. So how many electrons can the p subshell accommodate?
6.
Okay, so it's going to be 6 k. अगर उस पे p subshell में वापस जाओ ना, this entire thing is the p subshell. So there would be 2 electrons buzzing in the pz. There would be 2 electrons buzzing in the py, and there are going to be 2 electrons buzzing in the px. So maximum amount of electrons in the entire subshell would be 6. Okay, so this would be maximum. ये बाकियों को clear है अहमद? ये बात is this clear?
Yes.
And this one will have maximum of 10 electrons. And this one will have this one will have a maximum of 14 electrons. Right? So let's recap everything. Okay? What did we learn? We learned that electrons are so what we learned was what we learned was that electrons exist in spaces around the nucleus, which are your orbitals. You got a spherical region, that's an s orbital, p orbital. There would be 3 different types of p orbital depending on the orientation. You have a d orbital. There would be 5 different orientations of the d orbital. The electron could exist or occupy regions around the nucleus in 5 different ways if it's in the d orbital. And then you have an f orbital, right? And you group them together, that's a subshell. This subshell can have a maximum of 6. This entire subshell, if you consider this together, okay, that's maximum electrons it can accommodate is 10. And this one will accommodate, the F subshell will accommodate 14. So now coming to the main question, which is how do you write the electronic configuration? Now we figured out that electrons exist in orbitals, right? And let me show you what an atom would look like. Okay, let me show you what an atom would look like. So let's say I've got a sodium atom. The sodium atom has 11 electrons, right? It was pehle kya tha? It was 281, right? So now the electronic configuration is actually it's going to be written like this. It's going to be 1s2, 2s2, 2b6, and 3s1. So this is the way electronic configurations are going to be written. So bari bari, I have to tell you. Now you know one thing, that's that what does S mean? You know what S means, right? You know what P means. So that means sodium has electrons in the S orbital. It has electrons in the. Actually, these are subshells. Electronic configurations are written in subshells. So you've got an S subshell, you've got a P subshell, you've got an S subshell, right? So that means that sodium has electrons in all of these areas. Achha, what is the notation? The notation is this number over here is the number of electrons in that particular subshell. It's the number of electrons in that particular subshell. So you can see that the P has 6 electrons, the S has 2 electrons, the S over here has 2 electrons. So this number on top, the tiny number on top, that's the number of electrons in that subshell. Or and then there's a number right in front of them. That is known as the shell number. And it's also known as the principal quantum number. Okay, that's the more proper word for that. So it's the principal quantum number. So shell number or principal quantum number. So it doesn't mean that you have 3 s orbitals. It just tells you the shell number. Okay, 2p doesn't mean you've got 2p orbitals. It means 2 is the shell number. Okay, is that clear? Or so वो quantity donate it doesn't tell you the quantity of s orbitals. It just tells you the shell number. So can anyone tell me what is the shell number? What does it tell you? I mean, you already know this from O levels that there are things called shells.
Period number.
नहीं वो तो है लेकिन वो तो but what does it represent? Like what? एक second खत्म हो गया. I said my question is, what does this 3 represent?
How much further the electrons are from the nucleus?
Period 3.
So basically, one thing is that the shell number tells you how far away the electron is, right? So in reality, what a shell number tells you is the energy of the electron. So it tells you how energetic the electron is in that particular subshell. So if an energetic electron would be further away from the nucleus, because they can overcome the force of attraction. So for example, I've got 1s1. That means the electron has very less energy. Because 1 means it's shell number 1. So that means first thing, the electron is in a spherical region around the nucleus, right? So the electron is buzzing around in a spherical region, but it doesn't have a lot of energy. So the electron would be very close to the nucleus, right? So that is 1s1. But what if it was 2s1? फिर क्या होता है? The electron would still be occupying a spherical region around the nucleus. But now the electron is more energetic. So the electron would be buzzing around or flying around in a much bigger space. Okay, it can travel much further away from the nucleus. Okay, so this electron over here is buzzing around, but it's more energetic, so the negative charge is spread over a much bigger area. Okay, is that idea clear?
Yes, sir.
Okay, you can have 3s1. So 3s1 means the electron is now, or the subshell is now in the third shell. So shell, asal mein na, shell is nothing. Okay, shell is not some physical thing. It's just the energy of the electron. So if the electron is in the 3s, then what will happen is that the region is going to be even bigger. उसी को बड़ा कर देते हैं. So you're going to have, it's going to be occupying a much bigger, it's going to be a lot more energetic electron, and that negative charge would be a lot further away. And the same applies to P and D as well. So further away wali baat sahi hai ke, and that is what would happen in O-levels as well. In O-levels, you had a simplistic description of the same thing. The electron was actually further away. Ki wo O-levels wala hamara kidhar gaya. Like if the number of shells increased, the electrons became further away. So what that basically represented was that the electron is more energetic and it will be much further away from the nucleus. And that is what a shell number tells you. So it's the same orbitals or subshells. The shell number only tells you whether the electron is going to be close to the nucleus or will it be further away from the nucleus. And all of these shells, they can be overlapping. So let me draw sodium. So if I draw sodium, it's 1s2. अच्छा लगे ये बात clear है? You can message कर लो पहले. ये clear है?
जी sir.
Yes, sir.
कोई question तो नहीं है इसका?
No, sir.
एक second. So next part is के so I'll just leave it here. Right now we haven't figured out how do we main question abhi humne nahi kiya. We didn't figure out how to put electrons in these, like how do you figure out that this is sodium's electronic configuration. Right now I'm just going to leave it here. Okay, I'm going to draw the sodium atom. So sodium is what? If you look at sodium, it's 1s2. That means there's an s orbital. So this is the nucleus of sodium in the center, right? So it's got 1s2. What does 1s2 mean? It means there's a very low energy subshell and it's got 2 electrons in it. So sodium has 2 electrons that are very low energy, and these 2 electrons, or the negative charge of these 2 electrons, is spread in a very tiny area around the nucleus. Then you got a 2s2. That means sodium has another spherical orbital, but this one is bigger in size. And now in this spherical region, you got slightly more energetic electrons, 2 of them, 2s2, right? And these electrons are occupying or buzzing around in this much bigger space. I said, remember, the orbitals can overlap. So the 2 electrons over here, it doesn't mean that they are, let's go bada kar le. I said, it doesn't really mean that it's, this electron over here. It doesn't mean it's more energetic, so it might go into this red region as well, but the energy is of a 2s, so that means it's flying around. So it would be, there's going to be a higher probability of the electron being much further away, but it doesn't mean it's, so the orbitals can overlap. There's no issue with that, but even if this electron, like if it's buzzing around, let's imagine the fly is passing through, it can enter the red area as well, but the negative charge of the 2 electrons, which are at a higher energy, it would most likely be much further away. Okay, idea clear?
जी sir.
So then similarly you have,
Yeah.
so then you had 2p6. 2p6 means, what does P mean? P means the P subshell. P subshell means that it's got 3 axes. So you have, so you got a So you got a px, py, and pz. So that means if the p has 6 electrons, that means the 2 electrons that are in this px orbital. So there are 2 electrons that are buzzing around in this area over here, and there are 2 electrons in the py. So that means the negative charge of 2 electrons, they're buzzing around in this area, and there would be a pz. And the negative charge would be buzzing around on the z-axis, right? So it's creating a very messy picture. And then there was a 3s1. 3s1 means that there's one electron that's very energetic, and it's occupying an s orbital, and that electron is like really far away. So it's very energetic, so it will be occupying spaces much further away. And if sodium were to lose electrons, which electron will it lose most likely? It's going to lose the outermost electron. Okay. So the diagram, I mean, the old O-levels diagram is a simplistic version of the same thing. That there were 2 electrons very close to the nucleus. That was the first shell. Then there were 8 electrons much further away. That was the second shell. And then there was a third shell where you had 1 electron on the outside. So you can kind of connect this with the old O-levels diagram as well. So like we haven't figured out how did I get this? How did I know sodium has electronic configuration like this? I'll just remember that electrons will be next class. We'll probably study this, that how to actually figure out an atom's electronic configuration. But right now, just familiarize or get to know this thing that the electronic configuration, electrons will be put in subshells, and each subshell will have a separate energy level, and each subshell will have a different shape, and it will have a different number of electrons that it can accommodate. Okay, is that clear?
Yes, sir.
Yes,
sir.
sir.
Or मैं say main basics हमने पढ़ ली. All we have to know now is the only thing we have to know, and also make sure that the old O-levels diagram is not wrong. It's the same thing. It's just a simplistic version of the same thing. So बस बाकी काम हो गए. If we have learned this, then all we have to figure out is how did I know that sodium's electronic configuration is this? That's the only thing that's left. तो चलो ये फिर हम कल करते हैं, ठीक है? Like how do I figure out fluorine's electronic configuration, or how do I figure out aluminium's electronic configuration? ठीक है? Clear है सारा?
जी
Yeah.
सर.
चले कल फिर बात होती है, ठीक है?
ओके सर.
Okay, take care. Allah Hafiz.